plus or minus for Vx and Vz for
Yeah.
and so
So if you were to go back to the lecture on week 9, is it week 9? Yeah, week 9. And I did explain that in I think I did explain that on Monday. Is it Monday? Wait, let me recall. Yeah, I did explain that on Monday. So if we were to look into, is it Monday or even earlier? Or week 8. Arisha, you have to look on week 8 on Friday. Okay, but I will briefly go with you. Okay. So she asked how to analyze positive or negative. Okay. Like for this case, it's dependent on the direction of the shear flow. Okay, we are interested in element A. It's dependent on the direction of the shear flow, the arrow. Okay, so based on the force now, this one is on force Vy. Okay, so based on Vy, okay, the shear flow at element A is going from left to right. Okay, and on now this is based on Vy, and based on Vx, okay, is going from right to left. Okay, so when that's the case, okay, you will the one with the higher magnitude, the magnitude, the direction with the higher magnitude will be if this is element B, if Vy, okay, is moving in this direction, for example at 2000, okay, and this is your shear stress, due to Vx is moving in this direction, it is at 1000. So the resultant will be moving in this direction in 2000 minus 1000 is equal to 1000. Arisha, is that better now? Does that make sense? Okay, that is all. Okay, you cannot point to positive or negative. Okay, as long the value is higher, it follows the direction. Okay, the higher direction. I mean the higher magnitude direction. Okay. Okay. Coming back to here. Right. So we have constructed our Mohr circle down here. Okay. So how do we use this value? Okay, how do we use this value over here? Right? Relating to our Mohr circle. Yes or no? The loading conditions are what? Are different. Right? One is due to just uniaxial. The structure that we analyze is not uniaxial at all. Okay. So I'm now going to construct. Okay. I'm now going to put in our U strength. Okay. Our U strength into our Mohr circle that you can see now. Okay. So I'm going to put our U strength. So the U strength is like a box. Okay. So this is going to use wait 2 4. I'm going to use it 2 4 6. Okay. So you have seen I've constructed a box. Okay, you can see now I've constructed the box. So what does this box mean? Okay, where do we get this value? This value over here is our stress U. Okay, this value over here is our compression stress U. Okay, so you will ask me, Eugene, where is that stress U come from? The stress U is come from this point over here. This is also known as our stress what? U. Okay, right? You can see that, right? So you have stress U from the top Mohr circle, which is acquired from material property. And then now we put into the Mohr circle now. Okay, so what I'm trying to say is this. Okay? If our circle goes in this area, the shaded region, if the circle go outside the shaded area, okay, the material will yield. Okay, material will yield, or structure will yield. If or when the circle is in the shaded region. Okay? So it has to be what? Inside. Okay? It has to, the circle has to be inside the shaded region. And this point over here, is stress U divided by 2. And this point over here is minus stress U divided by 2. Okay? It has to be within that operating box. Okay. So now, how do we select material then? How do we know the material or not? So the thing to do is we have to calculate, we have to determine stress A and stress B. Okay. So note, stress A and stress B are the what? Principal stress. In the loaded structure. Okay. So there are a few things that we have to check. Okay. We have to make sure that the stress B is greater or minus stress B is not less than stress U divided by 2. And stress A has to be smaller than stress U divided by 2. Sorry, the other one is greater than, not less than. And then, the other direction you did, come on. And then we have to make sure that tau max, right, is less than stress U. What am I doing today? Okay, I'm doing something silly today. This is stress U. Okay. So that is why determining the principal stresses are so critical, right? Because at the principal stress, the shear stress is equal to 0. Okay. Yes. Because it is the radius of the circle. Because over here, right, over here, this value over here is stress Y divided by 2. Over here, yeah, that is our U point, positive U point. Okay, then on the left-hand side is our negative U point. So from there, we can construct our operating bracket. Okay, the top one, because of the fact that the tau max over here is stress U divided by 2, right? So that's why over here is stress U divided by 2 also. Yep. Okay. Wait, I just say yep just to say yep. Can you repeat your? Yes. Okay. Right. So this is how, now, after you've seen so much, this is how, right, we relate what? From uniaxial test, okay, from uniaxial test, the material acquired from uniaxial test to what? To structure analysis in combined loading, okay? So the only way that we can relate them is through what? Mohr Circle, right? The only way we can relate them is through Mohr Circle. So the most important thing is the what? The principal stress, because the principal stress is where shear stress is equal to 0. So it's important that we know at shear stress is equal to 0, where are we? And the maximum shear stress, okay? And the maximum shear stress. So we know how to calculate this now, okay? Now we are doing Mohr Circle. You have done combined loading, so now we are doing this stage now, okay? Then we can start selecting the right material. But before we go there, we have to learn 3D, okay? Before we go there, we have to learn 3D Mohr Circle. Most of the time, 2D is fine, but when to use 2D and when to use 3D is critical, okay? So now I'm going to introduce to you 3D Mohr Circle, okay? Now 3D Mohr Circle is still circle, okay? I'm not asking you to draw a sphere, okay? So now let's look at 3D Mohr Circle. So I will do an example on how to construct 3D Mohr Circle, okay? Then I'll do the theory part. Okay, I'm going to show you how it works. So we are going to construct an element . Okay, so this is our element, and I'm going to draw our relative transformation. Okay, so over here we have 30 megapascal. We have another force coming here. We have it at 20 megapascal. And then we have a shear, and this shear xy is equal to positive 20 megapascal. And then that's it. Okay, so this is a 3D Mohr Circle. Why is it 3D? Because it's in a what? A cube now. If it's a square, it's 2D. Okay. So now we are going to write this out. So from here, we know that stress X is equal to 30 megapascal. Stress Y is equal to minus 20 megapascal. Okay. Then we know stress Z is equal to what? 0. There's no forces acting on stresses acting on it. That's why we call stress Z is equal to 0. Okay. Then we know that stress XY is equal to shear stress YZ, and this is equal to plus 20 megapascal. Other information we know is stress, shear stress Zx is equal to shear stress Zx is equal to 0. Another information we know is shear stress Yz is equal to shear stress Zy. They are all equal to 0. Okay. Right. So from here, why is equal to 0? Because nothing is given over there. You can assume it to be equal to 0. So now we construct our 3D Mohr circle. Okay. So now I'm going to draw our 3D Mohr circle. So in 3D Mohr circle, you have 3 circles. 2D Mohr circle, you have what? 1 circle. Okay. Right. This is our normal stress. This is our shear stress axis. So this is our normal stress. This is our shear stress. Okay. So we'll call this 10 minus 10 minus 20, 10, 20, 30,